My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with the Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. This is episode number 33 of the 120 Days to Jamb Chemistry with Flash Isaac. In the previous episode, we looked at electrolysis, and the applications of electrolysis are extraction of metals, purification of metals, electroplating, then preparation of some importance, even sodium hydroxide. You can prepare them via electrolysis, plating of metals like even silver. Use silver to coat aluminium. That is an application of electrolysis, electroplating. Now, in electrolysis, the major electrodes you will see are platinum electrodes, carbon electrodes, copper electrodes, and some inert electrodes that way. In those cases, these electrodes, they don't really affect discharge. But when you see mercury electrodes and sodium, know that sodium must be discharged. Or copper electrode with copper salt, those two cases will affect discharge. Apart from that, the other electrodes in Jamb level are basically inert and they won't affect the deposition or discharge. These are common electrolytes and their products are the cathode and anode. For acidified water, which is dilute H2SO4, the product at the cathode is hydrogen gas, 2 volumes. In H2SO4, we have hydrogen ions from the acid and hydrogen ion from the water. They both migrate to the cathode and they are deposited. The product will be 2 volumes or 2 moles of hydrogen gas. At the cathode, OH minus will be discharged, and at the end it is oxidized. Oxygen gas is given off. Then for concentrated sodium hydroxide, the product at the cathode is hydrogen gas. The product at the anode is oxygen gas, and OH minus will be preferentially discharged, and another OH minus from the solution. OH minus from water, OH minus from the solution. So they are deposited there. For concentrated sodium chloride, which is brine, the product at the cathode is hydrogen gas, and hydrogen ion is preferentially discharged. Meanwhile, the product at the anode is chlorine gas. Why? Although chlorine ion is higher than hydroxy ion in the electrochemical series, because of concentration and the fact that both chlorine ion and hydroxy ion are close in the series, chlorine ion will be preferentially discharged. And at the end, you have chlorine gas, because in the cathode, reduction takes place, and in the anode, oxidation takes place. For concentrated hydrochloric acid, the same thing that happens in sodium chloride concentrated happens. Here, at the cathode, hydrogen from the acid and hydrogen from the water ions are deposited, and at the end, the product at the cathode is hydrogen gas. But at the anode, chlorine ion and hydroxy ion, they migrate there. But because we are dealing with concentrated HCl, instead of hydroxy ion to be discharged, chlorine ion will be discharged, because chlorine and hydroxy ion are close in the series and concentration will affect. Now, hydrogen and hydrogen, they are the same thing, so you don't even know the hydrogen that is discharged. Fine. But for concentrated sodium chloride, sodium will not be discharged, because although sodium is more concentrated than the hydrogen ion from water, there is a big gap between sodium ion and hydrogen ion in the series, so concentration will not be able to effect. For concentrated copper sulfate, obviously copper is lower than hydrogen. The product at the cathode is copper, and the product at the anode is oxygen gas. Sulfate will not be discharged due to concentration, because sulfate and OH minus, they are a little bit far apart in the series. So OH minus is preferentially discharged, and at the end we have oxygen gas. And for molten sodium chloride, we have only two ions, sodium ion and chlorine ion. So at the cathode, sodium is there. At the anode, chlorine gas. There is no drama. Ladies and gentlemen, if you still don't understand this summary, it means you didn't understand the class in the first place. Please go back to that episode and watch until you understand. Welcome to Faraday's Law of Electrolysis. So long electrolysis is concerned, Faraday has two laws. The first law and the second law. Faraday's first law states that the mass of a substance discharged or deposited during electrolysis is proportional to the quantity of charge. Which means if an electrolyte is deposited, the mass of that substance that should be deposited or discharged, the mass is proportional to the quantity of charge. This is Faraday's first law of electrolysis. Now, charge is equals current times time, which means the mass deposited during electrolysis is proportional to the product of current and time. Direct proportionality means as the charge increases, the mass will increase. As the product of current and time increases, the mass that will be deposited will increase. Which means with time, if you give it more time, more mass will be deposited. In mathematics, in physics, in chemistry, you cannot solve with this sign. We change proportionality sign to equality sign. And proportionality sign to equality sign will give you equals constant. This and this are the same. So mass is equals constant times current times time. In electrolysis, the constant used is not K. We use Z as the constant. So mass is equals ZIT. And this Z is electrochemical equivalent. So this is everything you should know so long Faraday's first law of electrolysis is concerned. Mass is proportional to charge. As the mass increases, the charge increases. As the mass reduces, the charge reduces. How about Faraday's second law? When the same quantity of charge is passed through different electrolytes, the relative number of moles of the element discharged or deposited is inversely proportional to the charge on the ion. What does that mean? What Faraday is trying to say is that if you have sodium ion and you have calcium ion and you have aluminium ion, since the charge of sodium ion is +1, 1 farad quantity of electricity is enough to deposit 1 mole of sodium ion. Now, given calcium ion and the charge is 2, 1 farad of electricity will only deposit half mole of calcium 2 ion. Now, if you have this, 1 farad will only be able to deposit 1/3 mole. Look at this. If 1 farad is needed to deposit 1 mole, it simply means that 1 mole of calcium ion will need 2 farad to deposit. From here, it simply means that we will need 3 farad to deposit 1 mole of aluminium ion. So, the more the charge, the more the quantity of electricity needed to deposit that ion. Ladies and gentlemen, if you are given any question under Faraday's law of electrolysis, these formulas and common sense will save you. If you follow what I've explained so far and you understand this formula, you'll be able to answer any question when it comes to electrolysis and Faraday's law. The first formula is M is equals ZIT. Z is the electrochemical equivalent, I is current, and T is time. The second one, this is mass. Mass is equals molar mass or relative atomic mass times current times time all over the charge times the Faraday's constant. So mass is equals big M IT all over QF. Small m is mass, big M is molar mass or the relative atomic mass. Look at this. If you bring this big M here, it becomes mass over molar mass. And what is mass over molar mass? That is number of moles. So if you are looking for number of moles is Q over QF. That means current times time over charge times the Faraday's value. The discharge on 1 mole of electron is equals the Avogadro's constant times 1.602 times 10 raised to the power of minus 19, where Avogadro's constant is 6.02 times 10 raised to the power of 23 moles. So with this, your life will never remain the same when it comes to electrolysis and Faraday's laws. Now let's look at practical examples so you don't think I am just joking. If a given quantity of electricity liberates 0.65 grams of zinc ion, Zn ion, what amount of Hg2 plus will be liberated by the same quantity of current? Given the mass of Zn to be 65 and the mass of Hg to be 201. Look at what this is trying to tell you. It says that a particular quantity of electricity, was able to deposit 0.65 grams of Zn2 plus. Now, if you apply that same quantity of electricity into Hg2 plus, what will be the mass of Hg2 plus that will be deposited? With this, I don't think we need formula. We basically need wisdom. Look at this. If you are given zinc 2 plus, how many farads do you think will liberate 1 mole of zinc 2 plus? Since we have a charge of 2 plus in zinc, we will need 2 farad of electricity to liberate 1 mole of Zn2 plus. And what is 1 mole of Zn2 plus? 1 mole of any substance is also the same as the molar mass of that substance, which implies that we will need 2 farad to deposit 65 grams of zinc, which is the molar mass. If 2 farad is required to deposit 65 grams of Zn, so how many farad of electricity was needed to deposit 0.65? 0.65. From here, 2 farad times 0.65 all over 65 is equals S. And what is S? S will be equals 0.02 farad. So the quantity of electricity that we needed to deposit 0.65 grams of Zn2 plus was 0.02 farad. So what will happen if we apply this same quantity of electricity to Hg2 plus? Now let's see. For Hg2 plus, since the charge is plus 2, we will need 2 farad to deposit 1 mole. If the charge is plus 3, we will need 3 farad to deposit 1 mole. If the charge is plus 1, you need 1 farad to deposit 1 mole. So 2 farad is required to deposit 1 mole. And what is 1 mole? 1 mole is also the molar mass of Hg. 1 mole is 201. So if we need 2 farads to deposit 201, how many mass or what mass with this same quantity of charge, which is 0.02 farad, deposit? Let's call it S. Cross multiplying S times 2 farad is equals 0.02 farad times 201. S is equals 0.02 farad times 201 all over 2 farad. So once you solve this, you should get 2.01 grams, which means this same quantity of electricity which liberated 0.65 grams of Zn2 plus will be able to liberate 2.10 grams, 2.01 grams of Hg2 plus. Let's see the options. Option B is the correct option. We are asked to look for the quantity of electricity that is required in coulomb. Look at this. Remember we said that Q is equals IT, right? If Q is equals IT, it implies that this is the same thing as M is equals big M Q over QF. So add this to the formula bank because IT is the same thing as Q and Q is the quantity of electricity, while small q is the charge, whether it is +2, +1 or +3. From this guy, MQF is equals big M Q. Dividing both sides by big M, Q is equals MQF over big M. And what would that give you? This will still give you mass is 10 times charge. Copper is 2 plus, so charge is 2 times 1 farad, which is quantity of electricity, is 96500 all over molar mass is 64. So ladies and gentlemen, calculating this will give you 30156.3 as seen in option A. What current in amperes will deposit 12.8 grams of copper in 2 hours 30 minutes? Mass is equals 12.8 grams. Time is equals 2 hours 30 minutes. We must convert to seconds. So to convert 2 hours to seconds, that will be 2 times 60 to minutes times 60 to seconds. Plus, to convert minutes to seconds, we multiply by 60. 30 times 60. This will give you 9,000 seconds. So 2 hours 30 minutes is 9,000 seconds. To convert from hours to seconds, multiply by 3,600, which is 60 times 60. To convert from minutes to seconds, multiply by 60. So this gives us 9,000 seconds. And the mass of copper, big M, is equals 64. F is quantity of electricity 96500. This is Faraday's constant. That is basically everything we need. What are we looking for? We are looking for current. I is equals current. Food is ready. We have a formula that can do everything for us. From that formula, mass is 12.8 grams is equals molar mass 64 times current is what we are looking for, I, times time 9,000 all over charge. Copper is 2 plus. To know the charges of all these ions, we did electrochemical series. That gives you all the charge of the cations and anions. So from there, you know the charges that they will possess. So all over Q 2 times 96500. Current will be 12.8 times 2 times 96500 all over 64 times 9,000. So that is it. We basically substituted, and when solved correctly, that should arrive at 4.3 as seen in option C. That is electrolysis for you. This question says, how many farads of electricity is required to produce 0.25 moles of copper? Look at this. Copper is 2 plus. It has a charge of +2. This implies that 2 farads will be required to deposit 1 mole of copper. If 2 farads is needed to deposit 1 mole of copper, then S farad will be needed to deposit 0.25 moles. Cross multiplying 2 farad times 0.25 moles is equals S times 1. S is therefore equals 2 farad times 0.25. And 2 farad times 0.25 should give you 0.50 farads. Ladies and gentlemen, that is the option. Option C is the correct option. And the next one says, which of the following ions requires the highest quantity of electricity for discharge at an electrode? Generally, the higher the charge on the ion, the more the quantity it will need. If we are given the same number of moles, Al3+, we need the highest number of electricity to deposit. Multiply the number of moles by the charge. For option A, 4 times minus 1. For option B, 3 times 1. For option C, 2.5 times 2. For option D, 2.0 times 3. That will obviously give you the highest number. So option D is the correct option. And this question says, what number of Cu2+ will be deposited by 360 coulombs of electricity? Let's see something. I want you to still have the view of what we solved so far. Here, charge small q is equals plus 2. This is not a problem. Either they give you aluminium 3+, sodium 1+, calcium 2+, copper 2+. Then Q is equals 360 coulombs. F is equals 96500. What do we even need? Okay, number of moles. Food is ready now. This is a simple thing. Number of moles N is equals the quantity of charge IT is equals Q. So Q is 360. 360 divided by small q, which is the charge, 2 times F 96500. That is basically the number of moles. And if you solve that correctly, you should have 1.87 times 10 raised to the power of -3 moles. Ladies and gentlemen, electrolysis and Faraday's laws. This brings us to the end of the class. Please go and install the Flashlearners Jamb application. Install it and start playing with questions. You are the one writing the exam. You are the one that should be more concerned. Like every day, I wake up by 1 a.m., 2 a.m., 3 a.m., 12 a.m. I record till morning. Every night, I don't sleep. Why? To make sure you are able to access the video and learn. Most persons, most brands, they will choose to record the videos in app and sell for you for as high as 22,000, 30,000, 40,000, 15,000. You know what I'm talking about. And most times, the quality, if you compare them, it's not even as high as this. So I put more effort, sleepless nights, I upload on YouTube. You watch for free, you don't even pay to watch. Install the app and practice. That app basically costs nothing for your own good. So do that, prepare for exams, blast and give me your own success stories. A lot of persons, thousands and thousands of persons, testify yearly of how Flashlearners have helped them to blast Jamb. If you check some of the comments in my video, you'll see testimonies. So I'm not a fan of sharing screenshots or proving anything to you. But if you follow the videos, get the app, then you reach me anytime you have questions or problem or even personal issues, I shall attend to you. See you in the next episode.